Hello students, we are solving the IB Math A HL past paper questions, and currently we are solving the IB Math A HL May 2021 paper 1 time zone 2 past paper, and we will be solving the question number 5 of this question paper today. And you will be getting the links to all the previously solved questions of this paper and of the other papers in the description area in form of playlists. So without any further delay, let us start with our today's session, question number 5. And the maximum mark is 4. And the question is, given any two non-zero vectors, A and B, show that the square of the modulus of this vector product of A and B, that means the vector product of A and B is a vector. We are just taking the magnitude because it is the modulus. We are taking the magnitude and we are squaring it. So this will be the square of the magnitude of this vector A times the square of the magnitude of this vector B minus the square of the scalar product of A and B vectors. Fine, we have to show this. So we start with the vector product magnitude. I am writing like this. So you see A, B, these are in bold letters to show that these are vectors. You can write A in this form or you can write like this just to show that A is a vector. It is not a scalar quantity. Okay, either you put an arrow above or you can put this tilt below. So A cross B will be equal to, I'm just writing the definition. It will be the modulus of the vector A times the modulus of the vector B times sine theta, where theta is the angle between these two vectors. So if I square them, square both the sides, what do we get? This whole squared should be equal to this one squared times this one squared times sine squared theta. And since we have to come to the scalar product, what is the scalar product? It is, let me just write it over here. What is the scalar product of the vectors A and B? It is the magnitude of the vector A times the magnitude of the vector B times the cosine of the angle theta, where theta is the angle between these two vectors. So since we have to get to cos theta from sine square theta, we will be getting cos square theta because this is whole squared. We need cos square theta in place of sine square theta. We will be writing 1 minus cos square theta in place of sine square theta. Okay? Because sine square theta plus cos square theta is equal to 1. So this is equal to square plus modulus of B whole square and 1 minus cos square theta. Or now we will be just expanding. So this is this whole thing times 1. Okay, minus the same thing times cos square theta. And we have seen that the scalar product of A and B vectors will be this expression. So this is just the square of the expression that I have shown. This can be written as equal to modulus of A whole squared times modulus of B whole squared minus this is the scalar product of A and B vectors whole squared. Okay, proved. Show. Okay, show. Okay, so therefore we have completed answering this question number 5. We'll be solving question number 6 of the same paper in our next session. Thank you for staying with me till the end. I'm Nilanjana Sanyal. I tutor IB Math A, SL and HL students from within India and outside India. And I'll be starting my group online math tutoring sessions from the month of July. So if you are interested in joining my classes, you may contact me for more details. You are seeing my WhatsApp number, you are seeing my email ID getting displayed. You may text me, you may call me, you may mail me. And we meet again in our next session. So till then, bye.